We're solving problem 11 from the 2024 AIME1. Each vertex of a regular octagon is independently colored either red or blue with equal probability. The probability that the octagon can then be rotated so that all of the blue vertices end up at positions where there had been red vertices is m over n, where m and n are relatively prime positive integers. Find m plus n. Now, to start this problem, we can just start considering the cases of how many blue vertices there can be. There can be up to a max of 4 blue vertices and no more, because then it wouldn't be possible. So if we have 0 blue, we have one case. If we have 1 blue, we can rotate it 8 times. If we have 2 blues, we can similarly calculate this to be equal to 28. And then for 3 blues, we calculate 56 using the choose function. If we have 4 blues, we can split this up into cases. The first case is where we would have an octagon going like now the circles, the vertices I'm circling means they're blue. So this would only have 2 cases. The next case, if we have an octagon, hang on, if it's circled like this, it looks weird, but if it's circled like that, that only yields 4 ways to rotate it such that it works. And then we have 2 more cases that work. That's not good. So our next case is where, similar to this above case, these 2 circled, but these 2, instead of the bottom 2 vertices are circled. This yields 8 ways to rotate it. And then our final case we have to consider, this is the final working case. When you're doing the test, you just have to test things out. Our final really working our working case, it's like this, where all 4 of 1/2 is selected. This yields 8 ways to rotate it. So the total number of ways to have red or blue vertices on an octagon is 2 to the power of 8, which is 256. We can then sum up all these numbers and divide by 256 to get m over n, and then we just add them. So we do 1 plus 8 plus 28 plus 56 plus 2 plus 4 plus 8 plus 8 over 256. All this on the top gets us 115 over 256. And adding 115 and 256 gives you 371. So that is our answer for this problem.